Alright, so we finished the last video with finding this upside down quadratic model. A was negative and so forth. Now at times you got the model, but we want to use it. So it'd be nice to get predictions from this model. And so for instance, I know I've got at the value of 5, according to this, I have 275, but what did the model predict it would be? How far off are we? And the way to handle that is actually instead of writing y equals here or here, we could do it either place. So back here, if instead of starting off with y equal ax, if I use the f of x notation and I say f of x equals, notice nothing changed. I mean, it plotted everything the same and so forth. But the difference is if I use this notation, then if I just come down here and open up a new space, I could say f of 5. And notice it says, oh, it's predicting 293.75. And if I come over here and click and try to find 5, notice it says 293.75. So actually either of these is a way to predict or to evaluate the model. So if I want the model evaluated at a different number, say 9, I could just click over here near 9 and I got it right on there. So the model predicts 9 should have a value of 316.95, or I could just go in here and say f of 9 and 316.95. So if I change the f of x or change the y to f of x like this, then I can evaluate it tabularly this way. I can always, when it's graphed here, so I'll even turn that off to make sure that all I'm doing is looking at the red one, and it gives me values all along here. Right, so I can get x and y values just by clicking on the graph and tracing along it. Okay, so I can always do that, but to get this tabular thing, I need to give it a name with the like f of x notation or something. Now, I called this f of x up here, so here I better use a different name, so I'll call it g of x. And but once I have that, again, see, they are the same function, g of 9, and I get the 316.95. Now the difference is here, these constants are stuck in g here, but up in f, if I hit these sliders and move them around, that's going to change this 316. So if I move that from 5.8 to negative 1.8, oh, that's not 316 anymore, it's 325. Okay, this one stayed 316 because that 5.8 didn't change, so I'll move it back to minus 5.8 maybe. There we go, and we're back to the same value. Okay, so that would be a couple of ways to evaluate my model once I make it. I can either just trace along the graph and look at XY pairs that way and go until I get to just where I need to, or I can, instead of just using Y's here, give it a name like F or G or H or something like that, and use that of x notation, and then just evaluate it. Say, oh, I want an x value of 9, that gives me the y value of 316.95. So there we go. That's how we evaluate our quadratic models. I got to turn it off here somewhere. There we go.